So, okay. Today is the day I told you I was going to tell you about the story of graphene, which is like my favorite law and technology, intellectual property, material science story in the whole world, because I think it really illustrates the importance of intellectual property rights to the field of material science, and you can really extrapolate that into engineering and any form of computer coding. It doesn't matter. But what I wanted to talk to you today and use it as an allegory for the importance of intellectual property rights is the story of graphene. So the question I begin today with is, does the assertion of formal intellectual property rights inhibit or promote the dissemination of scientific knowledge? Scientific journals are the way we really exchange scientific information. Scientific journals serve as a two-sided knowledge platform that facilitate scientific discoveries. Journals offer an outlet for scientists to disclose their findings in a way that allows them to highlight the importance of their discoveries, via the peer review process. And at the same time, scientific journals are the principal means by which follow-on research is done. So scientific journals are a good thing for scientists because they get the prestige that comes with publishing a peer-reviewed article. And at the same time, it's the way all of the rest of us scientists exchange information and conduct follow-on research. Who hasn't done a research paper here without looking at research that was done by somebody else in a scientific journal? So scientific journals are really the way we communicate as scientists, our discoveries, our thoughts, our insights, and they're the way that we inspire follow-on research and discoveries. So for scientific discoveries with potential commercial applicability, researchers may seek to establish formal intellectual property protection. So when you come nowadays, you can't just be a scientist. You have to be concerned with the commercial application of your scientific discovery, unless you're Bill Gates or Elon Musk or somebody like that that can afford to give this stuff away. But as scientists, you have to not only be concerned with the dissemination of your knowledge, but you also have to be concerned with your competitors, and you have to be concerned with controlling that scientific knowledge. After all, like we've talked about, it took a lot of work to come up with whatever the invention is, the better mousetrap, or let's say an exotic material like graphene. That takes a lot of insight, that takes a lot of work, that takes a lot of money, it takes a lot of time. So as a scientist, you want to do two things. You want to tell the world about your discovery, because that's the way science progresses, and you want to probably use a scientific journal to do that. But you also, as a scientist, want to protect your intellectual property by asserting intellectual property rights that allow you to control how that knowledge is exploited. So the question is, does the assertion of patents and other formal intellectual property rights inhibit the dissemination of scientific knowledge, or does it facilitate it? Any ideas? Any thoughts? Believe it or not, this has been exhaustively studied. How would the assertion of intellectual property rights inhibit the development of science? Can anybody think of a way? If, for instance, you discovered a new, fantastic, efficient battery suitable for electronic cars, how could the assertion of intellectual property rights over that discovery inhibit the development of science? Yes, sir.
Somebody else wanted to use that battery for their own scientific pursuits, but they couldn't because they don't own the IP.
They don't want to get sued. Exactly. And you can scale this right up. We talked about it previously. Tesla comes up with a new lithium battery, and Ford and General Motors and BMW and Toyota sit there and they say, gee, we'd like to develop an electric car, but we're going to bump up against Tesla's patent. So that's one way that it inhibits the development of and the advancement of science. Can anybody think of ways that it would facilitate the advancement of science? Yes, please. Yes. Do you know the story of graphene already? Oh, well. I hate it when somebody comes up with an answer that like spoils the, like the punchline of my class is now gone. But yes, that's exactly right. It encourages or promotes further research into different methods, into different methodologies, in other ways. You've heard the phrase, there's more than one way to skin a cat. Well, there's more than one way, it turns out, to fabricate graphene. As we're going to find out. And so in some ways, the assertion of intellectual property rights forces the brain power into a different channel. And scientists come up with ways around the patent. Ways such as exfoliation, which is in fact a more efficient way of developing materials. But that process would probably never have been developed when it was developed if it weren't for the assertion of intellectual property rights. Does anybody know how graphene was originally fabricated? It's a really cool story. Yeah, go ahead, yes. Exactly. I mean, can you imagine, it's 0.03 microns, but these guys in these two guys that eventually got the Nobel Prize fabricated it using Scotch tape. Does anybody know of any other way that graphene is fabricated today? One of the methods is exfoliation, and it's this really involved process. Has nothing to do with Scotch tape, but it's an excellent example of what you were just saying, in that the assertion of intellectual property rights in that case forced scientists to focus on another area and come up with a better way of inventing or fabricating graphene. So that, I'm getting ahead of myself, but this is my clever title for this little part of the lecture. It's called Graphene and Beyond, because I want to talk about not only graphene, but what has happened since the development of graphene. Because we want to answer that question today. Does the assertion of intellectual property rights inhibit the dissemination of knowledge and scientific development? This is a picture of the graphene matrix, or a one-dimensional picture of the graphene of a two-dimensional matrix. But anyhow, on the face of it, graphene is a simple material. It's derived from graphite, which is found in pencils and just about everything. Graphene is a single layer of carbon atoms, 0.3 nanometers thick, a million times thinner than a piece of paper, arranged in a planar, flat, hexagonal lattice. Yet it's 150 times stronger than steel and 20% more flexible. It conducts electricity better than copper or gold at a speed of 1 million meters per second. It sheds heat like crazy, and it's transparent as well as totally impermeable. Almost a supermaterial, really, when you think of it, at least theoretically, as I'm sure Dr. Eager has already explained to you, that oftentimes, well, one of the things he always says is no material is any stronger than the weakest atom in that material. And the other maxim that you can almost bet your life on is that oftentimes these supermaterials aren't as great as the initial hype. Something's always bedeviling about them in the details. And just going through the story of graphene, for those that don't know it, 2004, researchers at the University of Manchester and in the Institute for Microelectronics in Russia developed the first feasible approach for fabricating and characterizing graphene. they were able to isolate a 1-atom thick layer using 3M Scotch tape. They should have gotten the Nobel Prize just for that. But actually, that's not why they got it, but that was part of the reason they got it. But the thing about graphene is that this is a sort of the confluence of both material science and physics. It solved a massive problem, not only for material scientists, but also for physicists at the time, theoretical physicists, who had been grappling with this problem for decades, actually. Graphene has a significant potential in a wide range of applications, including transparent electrode materials, transistors, thermal interfaces, conductive polymer inks, corrosion resistance coatings and biocoatings, sensors, and in consumer products from bicycles to aircraft fuselages. And I'll add fan blades in turbines on the 787 aircraft or the 7770 aircraft, all made of graphene nowadays, or will be made of graphene. It's flexible, transparent, conducts electricity, lightweight, and can filter water molecules. All things considered, it could have the same impact in the 21st century as carbon fiber did, or steel in the 19th century. This fundamental discovery, confirming a central theoretical prediction, this is what I mentioned at the intersection of physics and material science, was published in Science. Okay, so this is the two-sided platform that we're talking about. This is how knowledge is exchanged or shared. In this particular case, the scientists who isolated and characterized graphene and were able to fabricate it for the first time published their findings in Science. And immediately, it spawned a mountain of research because everybody saw the commercial applications of this super product, and they wanted to be in on it. Like I said, everything from bicycles to sensors and biocoatings. These follow-on studies were wide-ranging, from explorations of the role of graphene in addressing fundamental questions of physics to consideration of how to exploit these materials. So there are two groups of people that were interested in the discovery or the fabrication of graphene. There were the people that wanted to exploit it, and there were also the theoretical physicists who wanted to understand the formation of this particular material, because in the world of theoretical physics, it is something that had been predicted for decades, but wasn't realized until these scientists in 2004 were able to, with their Scotch tape, isolate it. The fact that the fabrication and characteristic of graphene resolves this basic research question while being applicable to modern theoretical problems was at the heart of the decision of the scientists to publish and be awarded the Nobel Prize for Physics in 2010. Given the dual nature of this research, that is, its importance to theoretical physics and its importance to the commercial exploitation of material science, the researchers chose not only to disclose their findings in Science, but they also simultaneously applied for intellectual property protection. So here we have this massively important discovery that has implications both for theoretical physics and for material science. And the scientists do the one thing that all scientists do. They went out and simultaneously with publishing the paper in Science, they patent the process. So they owned it, the Scotch tape process. And the question is, does their assertion of these intellectual property rights, did it inhibit the development of graphene and the science around it? The assertion, by the way, of intellectual property rights has become so prevalent a form of disclosure. And now nobody, almost nobody, who comes up with a commercially marketable scientific discovery, who decides to publish it in a journal, ever fails to also at the same time assert intellectual property rights on it. Certainly if you walk into my office and ask for my advice, It will be that either before or at the same time that you publish the findings to the scientific community, you will file an application for a preliminary patent in order to protect your intellectual property rights. In fact, nobody does that anymore. But at the same time, the authors or the publishers of Nature materials and Science and some of the other journals out there began to be concerned about whether this assertion of intellectual property rights would sort of bog down the development of science. And they were concerned whether their journals were going to be able to attract and publish the latest scientific research anymore. They were really, quite frankly, concerned that how the assertion of intellectual property rights might inhibit the flow of information. Like contributors to any platform designed for knowledge sharing and exchange, scientists and the editorial staffs of these journals were concerned that the assertion of these rights might inhibit the flow of information. Now, in 2012, the Sloan School even studied this. There's an article published by the authors Murray and Stearns, who conducted a study to evaluate the interrelationship between scientific journal publication and patenting by examining the incidence of what are called patent paper pairs. That's not rocket science. It means exactly what it says. And what I advise all of my clients to do is when you have an invention, when you have something you want to patent and also want to publish, that you do both at the same time. And that's called patent paper pairs. A patent that is linked to the publication of some article. Now, patent paper pairs are also something that has been studied by the World Intellectual Property Organization. And they found that 58 patents, 82% developed by scientists from universities, are linked to articles. I'll wager that that's a lot higher now. I mean, I think this, forgive me, I think this slide probably goes back 5 or 6 years. I haven't changed it. But I would wager, I can tell you that in my world, it's 100%. It's not 82%, it's 100%. Nobody, unless the discovery does not have any commercial application, unless it's pure research, it always is accompanied by intellectual property, the assertion of intellectual property rights. Now, I want to talk just for a second, because it helps us understand the MIT study a little bit, what citations are, okay, when it comes to patent law. And it's important because you're going to need to know what citations are when you conduct your review of the state of the art as you're preparing your preliminary patent applications. So citation is a reference to a previous work that is considered relevant to a current patent application. Let me give you an example. If you're these researchers back in 2004 and you've got your roll of Scotch tape out and you've been able to isolate a 1 atom thick layer of graphene, and you want to publish a paper, one of the things you're going to do is you're going to do a search, a periodical search of all the peer-reviewed literature out there on graphene. That's just what any careful scientist would do in order to compare your research with what has gone on before. So what you'll do is you'll look for citations to a previous work that involves your particular area of research. Backward citations are patents that are cited by a specific patent. Forward citations are patents that cite a specific patent. Okay, really straightforward. Backward citations are patents that are cited by a patent. So if you file your preliminary patent application and you're demonstrating to the patent examiner that your application for a patent demonstrates an advancement on the prior art, you're going to want to call to the attention of the examiner prior patents. I keep using the mousetrap example, but if you've got this great mousetrap, one of the things that you're going to do in your patent application is you're going to use the prior citations of mousetrap inventions to demonstrate to that examiner that your mousetrap is a better mousetrap and represents an advancement in the science of mousetraps. And forward citations are patents that cite a specific patent. Okay? So you can use forward citations and backward citations to find out what your competitors are doing. It's called citation analysis, and there are companies out there. So let's say you've come up with this great new mousetrap. You can go online and hire a service that performs a citation analysis for you. You know, one of the things about being a great researcher is you don't have to know how to do everything. You need to be aware of some of these things, but for very cheap, very short money, you can get a citation analysis performed by you. There are companies out there that perform citation analysis. When you're putting together your patent application, you're going to want it. If you want to, learn to reinvent the wheel every time and become an expert in everything that you do, you can do the citation analysis yourself, or you can hire a company that does it. They provide you with a pie chart and shows you where all the citations, where all the prior art is. So that's one of the ways that if you're deciding whether or not you can commercially exploit something, you would do a citation analysis to see whether or not you have competitors that are either working on a similar invention, have published and haven't patented, or there are patents out there for similar devices. It's also useful to find out if somebody's stealing your information or you're infringing on your patents. So those are questions that can be answered by a citation analysis. In patent law, a citation analysis is a visualization of the forward citations in a patent pool. And by the way, a patent pool, which is another term you'll probably want to know about and be familiar with, is a consortium of at least two companies agreeing to cross-license patents relating to a particular technology. So let's say you have a mousetrap that you want to patent, and it's based upon technology involving a particular type of spring, which is necessary for your mousetrap, but has been patented by another company. You can't patent your mousetrap without infringing on the spring technology that has been patented by someone else. You might want to write them a letter, pick up the phone and call them, or have your lawyer write them a letter and propose to them that you form a patent pool whereby you share your respective proprietary intellectual property rights. And, of course, in return for either a licensing fee or splitting the profits on whatever commercially exploitable invention results, you'll enter into an agreement with them. So patent pools are very common because they're oftentimes overlapping technologies when it comes to these inventions. And one of the things that is very useful in sort of circumventing and preventing infringing is a patent pool. So going back to the Sloan School study, what they did is they did an analysis of patent paper pairs. First, they looked at pre-granted period with no formal intellectual property rights, and then the post-granted period, including IPR. So they looked at how many citations there were to this particular research prior to the assertion of intellectual property rights. And then they looked at that group of inventions or publications where there had been, for the period after intellectual property rights had been asserted. There's a practical kind of problem with this analysis nowadays because this Sloan study was done back in 2012, I think, and that was prior to the adoption of the new law in the United States, which makes it all the more important to file first. We are now a first-to-file country. Back in 2012, we were not. It was the first to invent, which was a very cumbersome system. But now, because we're a first-to-file system, nobody files or publishes without having filed. So this is kind of an outlier, this study, but it's worth looking at just because of what they did find. So the authors noted that their models established that patented articles were associated with statistically significant and strongly negative reductions in annual forward citations. So what does that mean? It means that what they found was that the assertion of intellectual property rights, when they performed a citation analysis, they found much less republication or mention of that research in patents and in articles that would be published later on. Why? Because people were afraid of infringing and they went in other directions. The articles in the journal Nature Materials experienced a yearly 5.2% decline in annual forward citations after the assertion of intellectual property rights. And 5.2% is a pretty significant statistically. At least it was to the authors. Patented articles in the journal Nature Biotechnology experienced a large and statistically significant decline in the level of annual forward citations. So these, according to the authors, these results suggest that seeking a patent for an article published in Nature or some of the other journals significantly hinders the follow-on citations. And their argument is it therefore significantly hindered the dissemination or the spread of scientific knowledge. So their finding was that the assertion of intellectual property rights did inhibit scientific development. There have been other studies. In 2015, researchers in Montreal published a study of the impact of patent paper pairs on the quality of biotechnology patents. The impact of patent paper pairs, according to that study, was negative. Once again, confirming what the authors of the Sloan study had found, that the quality of patents, the number of times it's mentioned, all went down after the assertion of intellectual property rights. There are other studies. In 2013, researchers examined the ownership of patents to show that, in this case, they were comparing academic patents with commercial patents, to show that academic patents, which are owned by companies, receive higher citations in their first years, diminish in the next few years, and then they disappear completely after 5 or 6 years. And why is that? What's the aim of companies? I'm sorry? To commercialize, to make money. Exactly. What's the aim of universities? Well, you may think it's to make money. What do universities say their purpose is? What do they claim? Spread the light of truth, exactly. We're supposedly disseminators of knowledge and information. But those of you who are paying tuition, I think that would be a very hard argument to convince you of. But yeah, universities are where basic research is conducted. They're not interested, companies aren't interested in the next step when it comes to a mousetrap or graphene. They're interested in commercially exploiting the benefits of this invention here and now. They have a board of directors, they have stockholders that they have to answer to. And so what companies are interested in is commercial exploitation. What universities are interested in is the dissemination of scientific and knowledge and the advancement of the art. And that's why patents owned by industries, but originally assigned to universities, are of a remarkably higher quality compared with patents assigned directly or obtained directly by industries. And this is due to the fact that patents assigned to companies mostly target direct commercial benefits, while universities and public institutions tend to answer basic scientific questions. So does IP, intellectual property rights, affect a researcher's tendency to generate more knowledge in future scientific activity? Proponents suggest intellectual property right assertions promotes innovation. Critics say that it has a negative impact. Going to some of the incentives, scientists share their ideas. So you write a paper and publish a paper in Nature or in some peer-reviewed journal. The good part is that not only do you get the prestige of having patented or published your information, but you know the old saying, publish or perish. If you want to be a member of the faculty here at MIT, let me tell you, I can't tell you how many patents Professor Eager has, but I know it's over 50. Professor, Alex Slocum, I know some of you must have had some of his courses. Good grief, I can't even think of the number of patents that, I mean, he gets up in the morning and he files a preliminary patent application before he has his breakfast. But there's a reason for that, and positions at universities like this really depend upon your ability to publish and to acquire and to invent, basically. So besides the reviews they can generate through licensing and innovations idea, academic inventors can receive peer recognition of their professional work. But if anyone has ever been to Alex Slocum's garage and seen that Rube Goldberg garage of his with all the machines and everything that and all the things he's patented, from bicycle seats to what's that thing that he patented, that foot rubber, something to massage your feet. I mean, he's the greatest, really. But he charges people for that, and he enters into licensing agreements with companies that buy his technology. So as a researcher or as a member of the faculty at a university, not only do you get the prestige of having published, but you can commercially exploit these things individually. And Alex and Professor Eager have turned this into a cottage industry. And well, they should, because they're the brightest minds that we have, and they should be benefiting from the work that they do. And we already talked about this, Tesla and Toyota and Mark Zuckerberg giving away their patent technology. I don't know if we talked about Facebook, but Zuckerberg had a project on artificial intelligence, and he gave away all of their intellectual property to that. Again, like Tesla and everyone else, what he wanted to do is he wanted universities to grab this, this patent technology, and what do universities do with it? They take the ball and run. They build on that research. So this is kind of like a cheap way, quite frankly, if you're Mark Zuckerberg, of getting people to work for you. You give away the patents to MIT, for instance, and the next thing you know, you have a bunch of people who are a lot smarter than he is working on the development of that patent technology. And guess who gets to exploit it later on? Exactly. Why are you in this course? That's the reason you're in this. That's the reason you're sitting here, understanding that. So that when a guy like Mark Zuckerberg decides that he's going to use your brain to advance his technology and fatten his wallet, you make sure that you are in for a piece of the action. There's a wonderful Nantucket Lyme disease research that's being done by Kevin Esvelt from the Media Lab over here. You can read all about it, but briefly stated, he's come up with this very inventive way of attacking Lyme disease. It has to do with genetic manipulation. But one of the things that Kevin decided to do before he embarked on this was to make one rule for his research, which was that he gives away all of his research. So when the government invested, and when other parties invested in his program to conduct this Lyme disease research and hopefully invent a cure for Lyme disease, number one rule was we're giving all this information away. We may exploit and we may assert intellectual property rights ultimately on what we develop, but the basic research is going to be made available to everybody so that the science advances. He found that it was he considered it a social obligation, and a lot of researchers feel that way nowadays. Anyhow, that's the Nantucket Lyme disease study is really interesting. You can Google it. I think he's a great guy, wonderful social conscience, brilliant scientist. I predict that they will come up with a cure for Lyme disease. Bill and Melinda Gates Foundation, I mean, what has he given away? Somewhere between 50 and 55 billion of his own money, and another 30 or 40 billion belonging to other people. True social altruism. Unlike Tesla and unlike Mark Zuckerberg, who are trying to raise all boats, they're just giving it away. They don't stand to make a dime. Just like Esvelt at the Media Lab with the Nantucket Lyme, these are examples of people with, I would say, laudable social conscience. So altruism or enlightened self-interest, we've already gone through that stuff. Is it a win-win situation? Yes, it is. But I want to get back to graphene because I think it's the thread that I'm trying to continue here and hopefully answer the question, does the assertion of intellectual property rights inhibit scientific development? So I want to talk about what has happened to graphene since 2004, apart from the mechanical exfoliation, which you talked about, piece of Scotch tape. As you anticipated, the assertion of intellectual property rights spurned others to perform research which caused them to develop other ways to obtain graphene, including liquid exfoliation, electrochemical exfoliation, and chemical vapor deposition. All these methods of developing and fabricating graphene have been developed since the mechanical exfoliation using a piece of Scotch tape was responsible for these folks getting the Nobel Prize in 2004. But their assertion of intellectual property rights, I would argue, has caused others to find out other ways. Like I said, more than one way to skin a cat. So their assertion of intellectual property rights has caused others to make an end run around the mechanical fabrication of graphene and find other ways of doing it: electrical, chemical, and vapor. This is the electrochemical exfoliation method, which was the first one to come along after the mechanical exfoliation method. And I argue that it wouldn't have been developed at the same time had it not been for the assertion of intellectual property rights, which spurred others to conduct this new basic research. Yes, sir?
A simple question is, I work for a company that simply bought a machine to do the exfoliation part of the graphene.
Right. Your company builds the machine for that?
No, it's not a company, it's a university, sorry.
Oh,
so my
okay.
question is, since they bought the machine, they probably use this patent to do research.
Sure.
Is that allowed or?
Well, if the question is, the university bought the machine to conduct the exfoliation method. Is that what you're saying?
Yes.
And is that allowed? As long as their check was good for the machine, absolutely. That's what the machine is for. So yeah, when you buy them now, what you do with the machine and what you develop with the machine may infringe on other people's intellectual property rights. I don't know what inventions or processes you're going to come up with by using that machine, but certainly you can use the machine without being concerned about infringing on intellectual property rights. And quite frankly, you may come up with something better than what has already been developed, which would advance the art and itself be something that could be patented. So the development of these new methods of extraction have led to new processes and methods that have shown that graphene can improve the mechanical properties of a composite as it can share the strain when added to the epoxy resin and matrix, makes things stiffer. So these methods were an improvement on the mechanical exfoliation method. So not only is it another way of doing the same thing, but it's a way of doing the same thing better. Again, the assertion of intellectual property rights paved the way for this. And besides developing new methods, the commercial application of these methods has been very widespread. As we said, we talked about aircraft fuselages and the fan blades contained in aircraft engines. This happens to be one of my favorites because I ride a lot of bicycles. They use graphene in custom bicycles that are manufactured now. Graphene being lighter and more conductive than carbon fiber. And because of the new methods for developing it, as cheap to use almost as carbon fiber, graphene is being used in all kinds of bicycle and sporting equipments, helmets, pads, and things like that. These companies, Darcy and Stuart Albert, are companies, again, that are concerned with exploiting the commercial applications of graphene, again, based upon the basic research that we talked about. And so now we have bicycles and, as I said, all kinds of other sports equipment that are, if not made completely of graphene, are incorporating graphene in the material matrix of the item that they're manufacturing. Again, this is more stuff about the graphene bicycle frame, which I just happen to be interested in myself. Here's a picture of a graphene bicycle frame, so it actually does exist. The electrical conductivity properties of graphene make it ideal for wireless systems. You know, on bicycles now, it's all about data. In the old days, we used to have to run a wire through the frame of a bicycle in order to get data. Basically, data was sort of an add-on to bicycles. Now it's incorporated in the design of a bicycle, and the properties of what the bicycle is made of is used to basically run current through the bicycle that allows you to keep track of and track all of your data. In bicycling now, if there isn't data, the saying is it didn't happen. So bicyclists are slave to, you know, if anybody do any swimming here? Well, one thing you need, in order to swim, if you're a competitive swimmer, you have to have, of course, a pool and a bathing suit. But the other thing you absolutely have to have when it comes to swimming is a clock. You can't swim without a clock because you don't know how fast you're going. Same thing with bicyclists. They want to know their cadence. They want to know their wattage. They want to know so many different things. They want to know how far they've gone. They want to know how fast they're going. All of this now can be incorporated literally using the frame of the bicycle, which lightens the bicycle. And if your bicycle is half a pound lighter than the bicycle of the person next to you, and you're in the Tour de France, and you stand to make millions of dollars in endorsements, which bicycle do you want? The graphene bicycle or the heavy carbon fiber bicycle? Obviously, you want the graphene bicycle. So laboratories around the world now make graphene in many ways with different purities, varying sample sizes depending upon what it's going to be used for. Obviously, you want the very best for an aircraft fuselage. You might be able to get away with a different form of graphene if you're a bicyclist, or if you're making a helmet or pads, athletic pads. Cat-like says it uses nanofibers maintain the strength of its Mixio helmets, which are now 10 grams lighter than previous models. Doesn't sound like a lot, but if you're in the world of sport. Has anybody been watching the World Championships for skiing recently? I know you don't have a lot of time on your hands, but this is the time of year where they have the World Championships of skiing, downhill, slalom, giant slalom. You know, the difference between first place and last place, 35th, is usually about 1.5 seconds. And you can see where material science really plays a very important role in those activities. And if you think that they are just out there for the love of the sport, take a look at the endorsements that Lindsay Lohan and the other great skiers have. Look at how they're festooned with the logos of corporations, all made possible by material science. Your faster skis, your more flexible skis, your skis can carve better because of the materials you use in them. So the development of these materials, besides having massive commercial appeal when it comes to televisions and communications and conductors and insulating materials, it really goes across the board. So, we talked about this. Graphene was sort of a throwback for physics. 2 guys in a lab and a piece of Scotch tape. It's nothing like, nothing like the discovery of gravitational waves or the discovery of the Higgs boson particles, which involved thousands of scientists and collaborations involving, multiple countries. These 2 guys sitting there with a piece of Scotch tape were able to amazingly fabricate graphene for the first time. But since they were since they did what they did, it seems inevitable, given the demand for ever improved electronic components for batteries, semiconductors, and everything else, that we'll learn how best to exploit this science. And this is, of course, the dream of manufacturing. I compare it to like kids with a Lego set. The only limit when it comes to graphene or other material science is your imagination. And I have some examples of that. So the question I have is, do you think the dissemination of scientific information is inhibited or promoted by the assertion of intellectual property rights? Let me go back to my examples. Give me just a second, because I think I skipped over them. These are materials that you may be familiar with. So what has the development of graphene, where there's been the assertion of intellectual property rights, where has it, what has happened? So since the discovery of graphene, all kinds of new 2D materials have been developed. Anyone familiar with staining? I wasn't, but it's used in high temperature superconductors and is composed of tin atoms arranged in a single hexagonal layer in a manner similar to graphene. The materials or the methods that were invented by these authors for graphene have been applied by other scientists who have been working in universities like this to develop other materials, and one of them is staining. Silicene, again, an allotrope of silicone, but arranged and fabricated in much the same way as graphene. Again, the way we fabricated graphene was the precursor, was what made the development of this material possible. It's made in many ways the same way that graphene is, and it has many of the same properties, but it also has properties that are enhanced and make it superior to graphene. And germanium, I'd never heard of it, but it's from germanium, okay? Like graphene, it's from graphite. Again, something that was initially of interest due to its electronic properties is a material made up of single layer of germanium atoms. Does that sound familiar? You know? Professor Eager.
To me, it raises the question of obviousness, because all they did was go down column 4 of the periodic table.
Well, that may be obvious to a professor at MIT, but I don't think it's so obvious. I think you're being very modest and generous with use of the term obvious. But in terms of intellectual property, it involves a different material. I mean, you can see where you can say to the examiner, my method is similar, but look what material I'm using. And so again, the point is that the development of graphene, even though it was protected by intellectual property rights, spurned all this other development. In many ways, you can say that the assertion of intellectual property rights funneled this technology, funneled this research into other areas. And there were all kinds of other spin-offs. I guess my point is, you can't stop technology. You can't stop the innovative process. For every invention that you come up with, there's someone sitting right here in front of me that can come up with a better way of doing it. And so it's my hypothesis that, and this is my evidence, that you can't stop the advancement of scientific knowledge or development through the assertion of intellectual property rights. If anything, they facilitate it. Yes, sir.
Do you see that development as the need to get around a patent and find a way to make a graphene substance or a graphene-like substance? Or do you see it as like human competitive nature? Somebody out there is making money, and I see an opportunity to compete with them.
What's the difference? Is it a competition of ideas or a competition of financial competition?
One is graphene technology. We really want graphene. The other one is, I feel like this animalistic kind of call to compete just on the basis of somebody else getting something that I'm not.
Well, I argue that there's no difference. Some people are motivated by money. Some people are motivated by pure science and knowledge. Whatever the motivation, underlying motivation happens to be, that motivation causes you to find a path. And that's what I'm saying, is intellectual property rights may erect a barrier here, but what it really does is it causes innovation by forcing people to come up with new ideas, forcing them to innovate, forcing them to use our creativity. But some people I think both motivations are good. I think commercial motivation, there's nothing wrong with making money. Remember that Lamborghini that I pulled up next to in the Prudential Center garage? I think that's a perfectly good way of perfectly good reason for doing what they do. But also, Professor Eager sitting back there with all of the patents that he owns, with all of the articles that he's published over the course of his career at MIT, just the advancement of the science alone, I'm sure for him, I don't want to speak for you, but is in and of itself the greatest reward. So I think whatever it is that motivates you, it doesn't really matter. The assertion of intellectual property rights ain't going to stop you. I guess that's my point. So, I don't know, show of hands. Does the dissemination of scientific information, is it inhibited or promoted by the assertion of intellectual property rights? People at the Sloan School says it is. I say it ain't. I say it ain't. I guess that's the question I'd ask you to think about. Next time, which will be next Wednesday, but which will include breakfast, we're going to start talking about how to actually patent something. And maybe as a class, we'll patent something just for the fun of it ourselves, okay? So that when you walk out of here, you'll know how to do it. Thank you very much for coming in. Again, privileged to stand up here and talk to you. Thank you for your questions. And I'll see you next week. Don't forget to sign the sign-up sheet. And
Tell us how your trial came out.
yeah, well, if it goes well, yeah. I'll tell you all about it. I'll tell you all about it.